Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So they'll get much more interesting and complex as we go on. So in this case, we're going to do data visualization, transformation, and feature selection. And if you remember earlier, the workflow that I had described in the introduction, we're kind of more or less following those steps that I've collected the data, and now I'm going to look and visualize the data and kind of identify problem areas or things that I need to do to get the data in a state where I could potentially feed it into a model. So we'll cover data insights. I mean, we briefly looked at the inline visualizer. We'll look at that a little bit more detail and some of the descriptive statistics and how we can kind of infer some information about the data by looking at some of the statistics. We'll scrub some data. Some of the data will probably have some missing values. We'll make decisions about whether or not we should add, delete rows. We'll do some transformations. We'll start applying some math operations. We'll actually utilize R script. R is very common. And so we'll utilize R script, for example, to do some of the data transformations. And then finally, we'll talk a little bit about feature selection. And in this time, what we're going to do is, again, part of the idea of scoping out the problem or the objective, what we're trying to do. In this example, we're going to predict flight delay. Now, I want to preference this real quick. We're not really predicting flight delay, but we're going to, in this sample, we're going to just work with flight information. Like I mentioned earlier, after lunch, we'll actually build a classification model, and we'll actually have some kind of output. But to set the problem up, approximately 20% of flights are delayed or canceled every year. And really many factors affect delays. It can be weather, mechanical issues, or air traffic control. And really what we want to do is leverage past flight and weather information to predict future flight delays. So we're making an assumption here that weather has a direct effect on flight delays. And there's a paper reference here called Predicting Flight Delays, where we've extracted this kind of experiment. So a lot of the data and the data sets that were utilized for this to support this paper that was written by these two fellows over in Stanford, we'll utilize that. And so the data sets that we'll utilize come from the Bureau of Transportation Statistics and the National Ocean Atmosphere Administration for the weather information. And just for this exercise, we're only going to use July to October 2013. So, and we'll download the data in a few minutes, but let's take a quick look at the data. So this is kind of a snapshot of the CSV file for the flight on-time performance data. And what we're trying to do is we're understanding, what we have and also determine, what we need to do to process it. So this is the kind of the first step. And you can see if we scan across here, we have some data information, the airline carrier. I see DL, that must be for Delta. Flight information of going from and to, the parking time of how long it basically sat on the runway or sat basically at the, I guess at the hub. I also see if it was delayed or not. So if it's a negative value, the flight left early. And we also have a binary field that communicates if the flight was delayed, and it's yes or no. So it's 0 or 1. And we have the arrival time with the same kind of information. So we have date information. We have the origin airport ID, the destination airport ID, destination information if it was delayed, and arrival information if it was delayed as well. So, when we look at this, what are some of the observations that can be seen? And we see that, for example, there are some categorical fields. So carrier is one of them. And, categorical fields are usually fields where there's a finite number of unique values. And each unique value represents some item. It's not numerical, and we don't want to infer anything from the value. So origin destination IDs are also category fields as well. So these are airport origin and destination ID. The next thing is hours and minutes. So they're concatenated in one field, and that potentially could be a problem when we want to join and do some interesting information with weather information. So we might actually have to go ahead and unconcatenate and work with that. Maybe we're just interested in just the hour as opposed to the hour and the date. And the other thing too is that the arrival delay, that's the thing that we want to predict, right? We want to predict whether or not it's going to arrive early or late or on time. And then we also have multiple target leaks. So we have the departure delay, also arrival delay, whether or not it was canceled. And we don't know really whether or not that data will have some meaning towards our modeling effort or experimentation effort. So we probably want to kind of eliminate them and clean them up to just kind of get rid of some of the noise. If I looked at the weather information, again, we can do a quick scan at the weather observations data set. It has, again, year, month, day. It has an airport ID. We'll assume that that airport ID, even though it comes from two different bureaus, comes from the same source as the flight information. But it may be different. We don't know. So if we look at this, time again is in hours and minutes, but one thing I know about the data set that it's expressed in UTC. So it really doesn't match with the flight information time unit. So we're going to have to do something about that. But the really good thing is that that we also have the time zone. And so we'll be able to actually adjust that time value because we have in UTC we have the time, and we'll be able to normalize that to a local time. The other thing too is that we have fields with missing values. So if we look at weather type, for example, here, lots of missing values. So what we're going to try to do is tackle each one of those problem areas and or enhance the data sets such that they're in a state in which we can go ahead and feed into an experiment. So the first thing what we'll do is we will go ahead and secure those data sources and kind of pull them into the system to work with. Now yesterday, this took an awful long time to upload, and it might be worthwhile to see if they already exist in some of the sample data sets. So let's take a look at that real quick. And let me go ahead and switch over to here real quick. All right, let's take a look. Okay, so let me go back to my workspace here. And let's just take a look at the data sets here to see if flight time performance. So this is from October. This is the weather data set. So I'm not sure if this is the subset or not. Let's just go ahead and upload it. So let's do a new data set from a local file and browse. And again, if we navigate to that folder that was in your zip file, you'll see this folder called Data Visualization, Transformation, and Feature Selection. Just go into there and you'll see them. So we'll do the flight one first. And we'll just keep the name there. I know that the flight information has a header. So I'm going to keep the default here and select OK. And that's going to start uploading down there. Actually, it's much, much quicker today. So it must have been the load, I bet, Kenji. Let's go ahead and also load up the weather information. So we'll do the same exact process here. Weather, it has a header file, and select OK. Wow, look how fast that is. Yesterday we had to do something very different. So you know what? So this particular session actually, what we do is actually have a plan for all the flight information, then we have a plan for all of the weather information. And I think we're doing okay with time, so we'll do both, and then we'll do a join at the end. So now that we have the two in the system, let's start working with the flight time information. So let's go ahead and create a new experiment. New experiment. And let's give it a name. We'll call it flight delay prediction, even though, unfortunately, we're not really doing any in this experiment here. And hit save. No. Oh. What we'll do then is go into your data sets here and look for your flight information. Did I pass it? Yeah, there it is. And make sure you pick the right one. If you hover over it, that was the default name that I had picked. So that's the Flight On-Time Performance 2013. And just drag it and drop it right onto the canvas. And I'm going to save it. Oh, can't save a draft without modules. That's interesting. So is everybody caught up? Yeah, don't worry about the save. Yeah, we'll get to that in a second. But y'all got there? And I should have asked, did folks want to take a bio break or anything like that before we get started? We seem to be going at a quick pace. We could do that if you'd like. Take 5 minutes or so. You guys good? Okay. Yeah? Okay, we'll keep going. So you're all here now? Okay. So one of the things that we're going to do first is ingest and set the missing values to a question mark. So recall that when we looked at the data set earlier, we found that some of the values were missing, right? So we want to kind of put some value in there such that it doesn't mess with our experiments. So what I'm going to do, and again, what we're doing is we're building upon a foundation. So right now we've been kind of clicking and navigating through the menu to find modules. You can keep doing that if you want, but I'm going to use the search window. So this is a really nice thing. And the first thing we're going to do is convert it to a data set. Nope, got to spell it correctly first. And I'm going to drag and drop that and connect them. So what converting to a data set does is it's actually taking it, the raw CSV file, or the raw data input, and converting it to a data set with a schema, as well as type values. So we'll go ahead and do that here. And you'll see, as part of converting it to a data set, we can actually have a couple of actions we could do here. We could replace values as we're doing the conversion, sparse the output, or set the missing values to some value. So it's actually defaulting to the question mark, and it's kind of what we want. So when it does this, we say, yeah, let's go ahead and set the missing value to a question mark. Let me go ahead and run that. Okay. And as I mentioned earlier, you can always visualize the output. And, it's always good to actually do this every once in a while to just kind of look into this here. And there's a few more missing values here, but we'll come back to those later. Another handy module is Descriptive Statistics. And this is where I had mentioned where there are some utilities within the service that actually provide additional insights into the data to kind of give you a notion of whether or not there's, for example, the data is balanced in particular columns or fields, if there's missing data, and just basically what the range of the data sets look like. So here's a module that I'll just go ahead and drag and drop here, and I'll connect the convert to data set directly to that. And if I go ahead and run it, we'll just go ahead and see some of the statistics about the flight on-time performance. Okay, let's go ahead and visualize it. Okay, and as you can see here, what it's generated basically for each individual feature, like year, month, day of month, the carrier, how many unique values there might be, if there's any missing values, min, max, mean, the mean deviation, and so on. So I can actually go ahead and scan these things, and I can also take a look at, for example, visualize that information. So it kind of gives in a histogram. So it kind of gives me a really good way to take a look at the data to kind of see if it's complete and well distributed. So if you recall earlier, we also identified that there were some target leak fields in the data set. We want to go ahead and eliminate those. So we have another module called Project Columns. And it basically does some manipulation on the data during some data transformation tasks. So we'll go ahead and drag Project Columns onto the canvas and drag and drop that there. And what we're going to do is introduce a new idea or concept. So as you remember, there were a number of fields that we did not want to include in the data set because they were target leaks. And those included the departure delay, the arrival delay, whether or not it was canceled, and so on and so forth. So what we're going to do is we're going to select what's called a column selector here. Oops, let me just cancel out of here. So this launch column selector, basically what it's doing is it's informing, you know what, let me just, give me 1 second here. I have this Dropbox hanging here. Let me just refresh my window real quick. See if it cleans that up. There you go. Okay. So I'm going to launch a column selector here. And it provides me with a user experience where I can actually select the columns that I want to work with and what kinds of actions. So what I'm going to do is I'm going to start with all columns because I want all columns to kind of cascade down. And what I want to do then is I want to exclude columns by their name and enter those column names. So one is the departure delay right here. The other one is the departure delay 15, which I don't know what that one is. The arrival delay. And the last one would be whether or not it was canceled. And what you're seeing basically when that drop down is, and one of the also benefits of hit and run all the time is it kind of cascades the schema. I found that sometimes the schema will, if I don't hit run, sometimes it will show up and sometimes it won't. It really depends on the operation in the module. So everyone should have something like this. And let me hit OK and run it. And obviously, when we run it, we probably should no longer see those columns or those variables. OK, let's go ahead and take a look at it. And if we do a quick scan, you can actually see how the columns in the tables are much shorter now, or rather fewer. Excuse me. Okay. So the other next task that we want to do is we also want to tackle the categorical fields. Specifically, we need to kind of change the metadata. We don't want to change the data, but we want to change the metadata about those fields. So we have another module here called the Metadata Editor. And I can drag that and drop that here and connect them. And specifically, we want to tackle those fields that we identified earlier. So if I hit the launch and basically kind of include by column name, it was the carrier, it was the origin ID, and the destination ID, and the destination airport ID. It was those particular three fields. And what we want to do is we want to make sure that we set them as categorical. If you remember that those were three fields that were categorical when we did the initial analysis of the data set. So once you have those three fields selected, we'll go here, and then we'll say it's categorical, and we want to say, yeah, it's categorical. So we want to set those fields to categorical. We'll go ahead and run that. And then the next thing that we want to do is, remember we had that time component that had the hours and the minutes. And what we want to do is we want to extract the hour from the time frame. We're only really interested in the hour piece. So for that, what we're going to do, as soon as this is done running, we'll drag and drop, obviously, a math operator, right? Because what we'll do is we'll do a division and divide by 100 to extract the hour portion of it. So let's just do a search for apply math and drag that and drop it. And then connect them. OK. Now, we have to tell it which column to operate on. So I want to do the launch column selector. And include by column name. And there were two columns, the departure time and the arrival time, that both had the hours and minutes concatenated together. So let's specify the departure time and the arrival time. And then you'll see a number of different math operation categories. There's trigonometry, some basic compare operations, rounding. What we'll do for this one is we'll set this to to operations, and we'll do a division, and we'll divide by 100. Right, basic math. We're assuming that we have a 4-digit field for the hours and minutes concatenated together. We'll go ahead and divide by 100. And then the other field that we want to set is the output mode. So really, the output mode is basically saying what we want to do is do an in place. So really what we're telling for this particular module is, hey, for the departure and arrival time, let's go ahead and divide that value by 100. And then the result of that, just do an in place, just replace the value right in place. Let's go ahead and run that. Okay, and then we'll go ahead and visualize the data and confirm that it did the division correctly. So we have both here, the departure and arrival time. I'll do a quick scan, and it looks like my assumption that the values, were 4 digits were incorrect. I still see some decimal points here, so we're going to have to round this and take care of this real quick. So let's just do another math operation. Drag and drop that here. And then connect the two. And then this time what we'll do is we'll just repeat the same process. We're going to launch the column selector. We're going to select it by name. We're going to tackle those two, the departure time and the arrival time. This time what we'll do is we'll do a rounding. We'll round by floor, constant 1. And we'll do it in place here. So we're getting rid of basically that decimal piece, and we're just really focusing and extracting on that hour. So if I go ahead and run that again, we should be done with the flight information. So next one we'll do is we'll tackle the weather information in parallel. Okay, let me take a look. Let me make sure mine works. Did you select the columns? Did you select the right columns?
Yeah.
Okay. Let me visualize it real quick. And if I scan it, sure enough, it cleaned it all up. So they look good. Are you okay? Okay. So Metadata Editor, let's see. You should have, you got that?
Yeah.
And it,
Departure delay 15, arrival delay cancelled.
yep, and you got all columns, okay. And you have exclude. All right, so let's go to the math operation. So the math operation, you have operations divide, constant 100,
Yeah.
and then the selector, you have CRS depart DEP time and CRS R time.
Yeah. Includes. Right? Yeah. So begin with no columns, includes column names.
And you have begins with no columns, include column.
I did before though, and it failed, so I actually changed it to, anyway, I'll run it again.
Okay. Yeah, that's a UI that's very confusing to me.
It's quite annoying, I don't know why. It still fails. I'll check the log. I'll do that. Column name as just that time is not allowed. Is not an allowed category.
Does this have the name?
Yeah, it's just that type. For some reason it's missing.
CRS dep time?
Yeah.
Okay.
Although when I actually check on project columns,
So your project column should be all columns exclude column names, departure delay 15, arrival delay, and canceled.
Yeah.
That looks good. And then the metadata editor, you have the launch. You have no columns, include column names, carrier, origin airport ID, and destination airport ID. And you have data type is unchanged, categorical set to categorical, fields unchanged. Then the apply math operation, you have category operations. Basic operation is divide, operation argument type is constant, and then the constant operations argument is 100. And then output mode's in place, and you have begin with no columns, include column names, CRS DEP time, and CRS ARR time. Okay. Well, I'll tell you what. Why don't you just kind of just delete that module from your workspace such that it will actually run and compile.
Okay.
And then let's continue on with the weather observations.
Okay.
And then, because that's actually a really good one, the weather operations, because that's where we'll start using R. And we'll bring in R.
Sure.
And you just won't be able to do the join at the end.
Yeah.
Is that okay? We'll just keep progressing. All right.
So I delete that module and keep going. Okay.
Yeah. So if you delete the one that's giving you the error, you should be able to run it successfully now. So now let's take a look at the weather one, and we can kind of pick it up a little bit, pick up steam a little bit, because you've probably done most of this stuff already now. Let's see, weather data set. Let me just find mine. There it is. It's the NOAA weather July through 13. And we'll just drag and drop that onto the canvas. So I'll put it next to and parallel to the flight on time performance. And we'll do the same thing. If you recall, we had missing values, so we'll utilize the convert to data set. And while we're converting it to the data set, we'll go ahead and take care of that missing value. In this case, I'm going to set the missing value to M. And the reason why I'm only setting it for M, it sounds arbitrary, but the original paper for that data set, they set it to M. So without going into great details of why they did it and stuff, I'm just going to follow what they did in the paper. So I'm going to go ahead and set that to M. And then the next thing, and then here, of course, if you wanted to, you could add the descriptive statistics to look at the data again. The next thing we want to do is remove some unnecessary fields through the data set. If you remember, we had some fields that were just kind of noise in that it was a very large data set. So let's go ahead and bring over a project columns and drag and drop that and connect that. And then let's go ahead and launch the column selector. And what I want to do is select with all columns, begin with all columns, and then exclude, and it's not going to show up. So let me cancel this real quick. Let me delete this real quick. So this is where the case where, for example, sometimes you need to run in between modules, because as you could see, when I went into that edit control, I didn't get the auto sense. It didn't kind of bring forward the schema. I could have typed it, but I know that some of these names are a bit long for me to remember. So we'll just run it real quick.
So if you did know the schema, then
You could type it in there directly. Yeah, you could.
you just run at the end and just does the entire workflow, right?
That's correct. That's correct. So let me just do that again. I'll pull over to project columns. Drag and drop. Connect it. Then launch the column selector. And begin with all columns. and I want to exclude a few of them. So some of the ones that we wanted to exclude, for example, that really didn't have anything to do with the prediction of weather, included, for example, the value of wind character, the wet bulb, both the Fahrenheit and the Celsius. There's a station pressure here. There's also a pressure tendency, pressure change, and sea level pressure. I know it's here somewhere. There it is. Yep. That look good? So here I'm utilizing the project columns as a way to kind of exclude columns by the column name, or exclude data by their column name. I could also exclude data by their type as well. So to do that, what I can do is select this little plus thing here, and it's going to give me another option to exclude things. And this time what we'll do is we'll exclude by column type. And we don't really need any of the column types that are of type string. Those column types would not have been projected unless I ran the convert to data set. So that's where some of that, it's kind of fuzzy about what the value is of a convert to data set, but that's probably the one thing that I've kind of extracted value is it applies kind of a data type to the column. So I can go ahead and select OK and run this. Exclude. Yeah. Mm-hmm. And that worked good. So if I looked at the data set real quick, I should see some of those columns removed. They're gone. Okay. The other thing too is that there were some missing values, and I could come up with a really complex scheme of how I might want to tackle that. But for the purposes of this conversation, this exercise, as well as showing you a bit more of the breadth of the application, the solution, let's go ahead and just remove the rows with missing values. So any place where there's a missing value, we'll go ahead and remove the row. So there is also another module called missing value scrubber. And I can drag and drop that there, and that's doing a manipulation on the data. And what we're going to do is, for missing values, we're going to tell the system to remove the entire row. And we're going to keep the columns. And what we're going to do for this column indicator here, we're going to do do not generate. So basically, the MV indicator column is just, it appends an additional column to tell you what it did, for example, for this task. And we'll go ahead and run that. Oops, I didn't connect it, sorry. There you go. And now we're going to, this is where it kind of gets a little bit interesting. So this was actually, if you recall, we had that time field, and that time field had two problems. One was, just like the other one, the previous one for the flight data, we had hours and minutes concatenated together, so we want to take care of that. And then the other thing too is that it was expressed in UTC, so we also want to correct that to local time. And we're fortunate enough to have basically a column in the data set that includes the time zone. So we'll utilize that as well. So to do that, just as we did earlier, we have these math operators. And I'm going to go ahead and apply math operation and drag that and drop that there. and do that. And we're going to select the column selector and by name, and we're going to select time. And just as we did earlier, we're going to select it to operations, and we did divide by 100. And we're going to set the output mode to in place. And then I'm going to do the same exact thing. This time I'm going to drag this and do, remember we did the rounding to get rid of that decimal? We'll connect these two here. We'll launch the column selector, column names. And it doesn't show up, but we'll type in time. And earlier what we did again was the rounding. We did a floor constant 1 and in place. So the same exact operations, which is right to the left of you on the flight data. And we can hit run. So at that point, I mean, the data is still in UTC, so we have to fix that. I'll be curious if yours works this time. Does it work in this time? Yeah. That's funny. You know what it is? It's just a slight, like you saw earlier when I was, like I had a space, for example, in the account name, and it's just hard to see. So now to adjust the time from UTC to local time, we're going to take advantage of that time zone field. And we'll just yet do another apply operation, but this time what we'll do is a subtraction. I guess you could do an add as well. We'll do that. And this time what we'll do is we'll select the operations, and we'll use a basic operation. We'll just do, let's say, kind of a subtract. Select, and what we'll do is this time the argument type will be a column set. So what we're doing is we're saying we want to specify, we're going to do a subtraction operation, and we want to select the columns to subtract each other from. So in this case, we're going to select the first argument. And in this case, we're going to select no columns, include column of column name, time zone. Right? And here, we're going to select by column name, time. So we're subtracting time zone from time, and the output mode will do in place. Basically, when you're done with the result, replace it with that column. Okay, so you can go ahead and click on the results and visualize it. And we want to look at the time value. And we can scan down here, and they look pretty good. You know, 24, 24, 25. That's weird, because we have a value here with an hour of 25, which doesn't make sense, right? So we're going to come back to that. And if I keep scanning here, I see another 25. 25. I just see some weird values in here. You know, when I've done this in the past, I've seen 27 and 28. Here's a 26. So obviously there's something wrong with that. And really what this means is that we need some more context around a date time operation. And what we're going to do is we're going to replace these three tasks with an R function that we had written, an R script that we can actually go ahead and interject in there. But but we'll come back to that real quick. Let's do one more thing. Let's remove the duplicate rows. So if you remember that there were some duplicate rows, so just through intuition, when we looked at the original time that we extracted the hour from, there were a bunch that had a minute of like 56. And so it's likely to get a unique hour when we set, but we don't really know what the data is like. So what we do know is that we want to kind of have a unique hour. We don't have multiple weather observations for the same hour. So to tackle that, what we want to do is yet another module called remove duplicate rows. And we'll just drag and drop that here. Connect them. Oh. Is this not on? Sorry. That should work now. There you go. Remove duplicate rows. And again, we want to select which column here. So really what we're saying here is that begin with no columns. And we want to select year, month, day, airport ID, and that one field here, which we should see. Oh. Oh, I don't see it. Hold on. Let me back up a little bit here. Let me just go real quick here. Oh, do you know what? When I did this, I actually should have selected the output mode to append, not in place. So let's just do that real quick. Let me delete this. And did you see what I did here? The output mode, I did append. I actually didn't want to do in place. I want to actually kind of append the result set. Basically tell the system, create a new column and append it to the end. Because we're going to use that value as kind of a key when we duplicate, we eliminate the rows. So go ahead and run that with that correction. And then this time when we go ahead and visualize the data, all the way at the far side of the road, you'll see a unique column that was generated by the system. And it should say something like, subtract time zone, comma, time, to kind of give you an indicator of the operation that it performed. And then this time, let's just take a look and make sure we got that right this time. Because when I was setting up the index to remove the columns, I noticed that field was missing. Yeah, so you see it right there? So subtract time zone. It's got that there. So then now let's go ahead and remove the duplicate rows. And I'll drag and drop this. Connect them. What we're trying to basically say is basically this is the filter. We're specifying a filter expression to basically key off of. So these are the fields basically that we want to utilize when for the system to determine whether or not there's a unique row or not, or duplicate row. So again, we'll go back and select year, month, day, the airport ID, and that subtract field. See down on the bottom here, subtract time _ time zone. So those are the keys that we want to use when evaluating if there's a duplicate row or not. And then the other thing too is I want to retain the first duplicate row. So what we're doing there is we're telling the system that, hey, when you choose to delete a row, always retain the first one and then eliminate the others. So let's go ahead and run that one. And then this next step you won't be able to do. We'll do a join, and then we'll do a join, because now we want to join the two data sets to kind of get a result set, because you didn't get the left-hand side running. But just follow along. And then we'll come back, and the last step is we'll replace those things with our script. So that would kind of complete everything that you need to know about doing all kinds of different data transformations and stuff. And then after we'll break for lunch. do come back for lunch. To me, I think that the best presentation, the meat of it, where you're actually doing some experimenting and modeling, is in the afternoon. And then you're also doing the deployment. So this is kind of like the basics. And we're also considering potentially consolidating the workshop to just kind of extend the experimenting the model to include a little bit more of this. When you guys are done, at the end of the day, if you have feedback on that, just let us know, because this could be tedious sometimes. But you're getting a good view of the product by kind of going through all these things. So let's now.
I'm behind. So removing duplicates was year, month, day, airport ID. Is that right?
And the subtract weather.
Yeah.
Got them?
Yeah.
Okay. So now what I'm going to do is I got 2 data sets, but really at the end of the day, I want to join them together. And I want to join them together in a specific way. And if I was to kind of build a model off of that, it would be that join data set that I would start working with. So as you can imagine, there's a module called join. So we'll take that, and we'll put that down here on the bottom between the two. And we'll take the output of the flight information and the output that we have so far of the weather information. And then the next thing that we have to do is to basically describe how we want to join the data together. So the join columns for the left, and this would be the left, which would be the flight information. We'll launch the column selector. And we'll select by column names. And we're going to select year, month, day of month, the origin airport ID, the departure time. So that's what that should look like. And click OK. And then the join columns for the right side, and that's the weather information. I want to launch the column selector. And I want to select year, month, day, the airport ID, and the subtract time zone down here. So again, I'm matching on year. The indexes basically into both of those tables are year, month, day, airport ID, and the time. And select OK. I want to do an inner join, so I can specify what kind of join type that I might want to do. I'll do inner join. And I'll keep the right columns, right key columns in the join table. So it's going to bring over those sets when I complete the one set. So let's just go ahead and run this. And this is basically joining the 2 data sets for the weather information at the departure airport. You know, it might be interesting also to do something very similar to at the arrival airport to see, for example, the weather at the arrival airport affected the prediction. So what we would do in that case is more or less repeat the steps. So we can do that here again. Just let me finish this running. Okay, so let me just slide that over here and select join again. Drag and drop that over here. And I'm going to do again the math operation here and the flight information on the left-hand side and the weather information on the right. And this time I'll just select different columns. So for the flight information, I'll go ahead and select again the year, the month, the day of the month, the destination airport ID, and the departure time this time. And then on the other side, I'll go ahead and select the year, the month, the day, the airport ID, and that subtract time zone. Okay. Do the inner join, keep the right, and then we can go ahead and run it. Now, of course, we have to kind of go back and take care of that problem where we had the time values that were greater than 24. I could have done that before I did the joins. I probably should have. But in this case, what I wanted to show you is how to bring RScript into Azure ML. And in this case, without going into a lot of detail in the RScript about what it does basically some data transformation on some of those columns that are within the data set. So let me just let this finish running. It's working now? So you can kind of oh, it did. All right, great. That's perfect. Or it could have been the system too. I don't know. So what we want to do is replace the NOAA weather observations data processing with an RScript, specifically those apply math operations. And we do have a module called execute RScript. And I'm going to take that and I'm going to put it to the side here. Let me just slide that over. Because really what we're going to do is this is the weather workflow here, and we're going to replace these math operations. And what we're going to do is, as you can see in the properties window, it takes RScript that you would cut and paste in there, and also kind of a random seed. If you go back to that handy sheet of paper, you'll see the RScript. And what it's doing is basically it's taking the year, the month, day, the time, right? And it's basically then concatenating the date fields and applying a proper time zone difference using POSIX. And then it's doing some extracting it, and then it's basically then extracting some of the other columns and then binding it. So let me go ahead and grab that. Oops. And hit copy. And then what I'll do is go back into Azure ML. And this little window here, which should expand out for you folks as well, just go ahead and do a shift insert. And you'll see it all there. Okay. And then what we'll do is we'll come back to this. And then we have to connect things. So again, we're going to circumvent these math operations. These were the math operations that did the division and the rounding, if you recall. And so we're going to take this missing value scrubber here and draw this into here. So that's the input to the data set. And then we're going to take the output here and put that into the remove duplicate rows. And there's a couple of other different inputs here as well. There's a secondary data set that if you want to input into your RScript. There's also a script file bundle. So if your RScript, for example, has some dependencies on some binary code, you can actually bundle it together in a zip file and then have references in your RScript code to those. And so what it will do is when it executes this, it will actually go ahead and unbundle that zip file and then resolve the references such that you can go ahead and run some of the code. So we'll go ahead and do this, and we'll hit run. Okay. You know what we could do too is remove at the end of this RScript. Let's just take a look at this and visualize it. And just to go a quick scan, what you'll see is adjusted date, year, adjusted month, adjusted day. These are new columns, and adjusted hour. These were new columns that were created by the script. Okay. They replaced basically month, hour, and day. And if we took a look at yep, that should look good. Okay. And what you'll notice here is the duplicate rows failed over here. And the reason why is because the column names have changed. So if I go back here, I can go ahead and fix these. And get my handy dandy sheet here. Sorry, I forgot what they were. Okay. So, so you want to remove those because, again, the R script had replaced them. And then specify year, adjusted month. So let me get rid of this one. Adjusted month, adjusted day, the airport ID, and the adjusted hour. And then that should just work. And then we'll just do one more module, and then we'll break for lunch. And again, I do encourage you to come back after lunch. It's the rest now we start getting into some real modeling and experimentation. And then John will presenting those two. He's a great speaker. And then afterwards we'll do we'll also put it into production. Yeah, this one failed too. You know what? I didn't clean this one up either. Sorry. But you get the gist. Here we go. That one. It's this one. So, boom, boom, boom. Get rid of this one. And then we'll just do, again, we'll just do, let's see, year, adjusted month, adjusted day, the airport ID, and the adjusted hour. And then that should work. Sorry about that. I missed that one. And that's because those columns were referenced in the, and actually, I probably I didn't take care of the other join either. Yeah, see, I failed to do this one too. Sorry about that. Okay, so we did adjusted month, adjusted day, the airport ID, and the adjusted hour. There you go. And then the final one is just basically, suppose maybe I wanted to isolate part of the data set. So for example, if I know that this data set I think goes from June 2013 to October 13, and suppose I wanted to work just with the October 2013 data, I can actually go ahead and split the data. So if I do a split, if I search for split, S-P-L-I-T, and drag and drop that, I could take one of these joins, put that as an input there, and then basically what I can do is I have different splitting modes. I could do split the rows, a recommender, a regular expression, or a relative expression. I'll do a relative expression, and basically I want to do it by month. So and actually I think it's adjusted month. So let me look at this real quick. No, it is month. Yep. So let's just do it by. So month is less than 10. So what I'm saying is just basically split the data, and I'm only interested in the left side will be the things that are, oops, gotta get the expression correct, less than 10, and then the right would be 10. So if I ran this, I could split the data and then kind of work with it, just segments of the information in the data. So this kind of really concludes a lot of the data manipulation and the visualization aspect of it. You got a chance to take a look at different modules for doing transformation and working with data, including arithmetic and statistics. Some of the visualization would be kind of like, for example, that statistical function where it would generate the statistics across the data set such that you can take a look at the normalcy of the data or problem areas and then kind of tackle it that way. There's also the visualization window too from the output, and you can utilize a number of the heuristic windows there too. After lunch, what we'll do is John has a short talk on predictive models. It's only about 15 minutes long. It's a really, really great talk. It kind of sets up on building a classification model. And he'll spend about an hour to an hour and a half building a classification model and comparing, for example, an SVM model to maybe a logical regression model working with some data. And then after that, I'll just jump in and spend about 15 minutes or so showing you how to publish it to a REST API. And then we'll be able to kind of call that REST API. We'll use the browser in this case, but as you know from a REST API, which is fairly standard today, it will be hosted as a service up in Azure, and you can call pretty much either from any application or web service. So it's a quick way to kind of build your model. Once you're satisfied with it, publish it right out. So more exciting stuff after lunch, I promise. And thanks for sticking with me.